Hello all, welcome to part 5 of the SecurityTube GNU Debugger Expert course and certification. In this video, we will look at breakpoints, examining registers and memory locations. Now before we begin, if you want the slides as well as the code files for this video, then as some of you have already done, you could go to the description of the video and there you would have the PDF and code file downloads. Click on the link. It would take you to this screen where you have the option to support us more by going ahead and purchasing the SGDE for $50, where you will get the course videos for download, a mock exam, the certification exam, and finally the certificate. Or you can go ahead and tweet this video and help us spread the word. Just a quick point, please ensure you tweet from the link here rather than the one down below the video, because we use this code to actually go ahead and verify that the tweet was done. If you haven't followed SecurityTube, you can follow us. If you're already following us, well, there's nothing much to do here. Remember to leave your Twitter ID and your email address so that we can go ahead and send the zip file out to you. Okay, now that the administrative stuff is out of the way, let's start the video. Now, let's do a quick recap of what we've learned from video 1 to 4, right? We've seen the basics of what symbol files are, how to load them up in GDB separately, or how to compile programs with symbol file support. We've also looked at how you can inspect the symbols using utilities like nm, and then how you can trace through what syscalls a program uses while executing by using strace. Now in this video, we'll get back to GDB and look at how program analysis is possible. Now imagine that a program is running. Now as a reverse engineer, exploit researcher, or simple plain developer who wants to debug a program, you would want to have the ability to peer into the program's memory, the CPU registers, and a ton of other stuff while the program executes, right? So there is something in GDB which can help you do that. Actually, there is something in every debugger in the world which can help you do that. And that is what is called a breakpoint. So breakpoints are basically, techniques which allow you to freeze the program right where it is executing based on some criteria. We'll come to that later. And when this program is frozen in time and space, matrix style, you can inspect CPU registers, memory, even look at variables and whatnot, and even modify stuff for that matter, right? So when you look at what is the criteria to break, well, there is a bunch of stuff you can do. The typical stuff which people use breakpoints with is a specific instruction or a function. When they want to actually look at what's going to happen there, what the function returns and things like that. You could even have conditional breakpoints, which we'll take up later in a video. So how do you set a breakpoint? Now let me actually go back to our little lab which we have set up. Once you download the zip file, either by tweeting or by taking the course, you would find these files in your folder. Now, what is SGDE video 5? Let's see. It's an extremely simple program. All it does is it takes user input via command line arguments and then calls a function called echo input, which basically copies the user input into a buffer of size 20 and just simply prints the buffer on the screen. That's it. Right now, as some of you are already wondering, this is maybe a buffer overflow attack, right? So let's say we take the debug version. Let me give it an input. Let's say Vivek. Just prints it back. Let me give something else. Vivek loves SecurityTube. Right? Oops. No external. We don't want to use characters which interfere, and I'm not in a mood to now escape stuff. So there you go. Vivek loves SecurityTube. And looks like there was a core dump, right? Fantastic. And the reason basically is probably what you already figured out, is that the buffer size was too small. Let's just make it simple. Vivek, hi. Right, seems to work. Okay, so the program has bugs in it. Fair enough. Right, this is ideally what we'll look at in later videos as well. Some more interesting ones with bugs in them. So try it out. You see that, well, it works some of the times, and when the input size is greater than 20, then it's going to fail. So let's actually look at how to load this program up in GDB. So we say, hey, GDB, GDE, debug, right? This loads up the program. Now, if you want to run the program from within GDB, then you can use the run command. And if the program expects command line arguments, you can actually give the arguments along with run. Alternately, there is something called set args. You can have a look at that to figure out how it works. So run Vivek would basically invoke the program. This is the absolute path of the program. Along with any command line arguments we pass, the program runs, prints Vivek, and then finally exits normally, right? Just exits. So this isn't of much use. Frankly, I could have run this program even outside of GDB, and I would have gotten absolutely the same result. So there is nothing really which helps here. So now let's come into breakpoints. So let me list the file. And let's say that we want to break as soon as the main function starts, right? So there are a bunch of ways to do that. The most reliable way probably is just to hit break, or you could probably, if you want, you could actually go ahead and just type in break main. You can give the address, a bunch of other things, even the line number, but just use break main, right? The moment you hit enter, what it says is really important. It says breakpoint 1 at, this is the specific address where the main function starts. And because, you know, we have all the symbol and debug files and all of that, basically says sgde-video-5.c line number 30. And if you basically do a list at 30, by the way, just an L is short for list, you would actually notice that this is where it kind of begins. Now you're probably wondering why it did not say 27. I leave that as a question to you. Please see if you can find the answer and leave it in the comment section. Now going back, so the program is basically at a breakpoint, and at this point it's actually frozen. So let's inspect the CPU registers. To inspect the CPU registers, you type in info registers. Oops, I did not run the program. You can actually set a breakpoint before running it, by the way. So let's run the program. And if you notice, the program ran, and basically, you know, the breakpoint which we had set has actually been hit. And argc is 2, which is, of course, argc2 means the first is nothing but the program binary location, while the second thing is the argument which you passed in, right? So now that the program has hit the breakpoint, let's look at the CPU registers. Now, people familiar with assembly language probably already can see all the EAX, EBX, ECX, and a ton of other things, right? These are the CPU registers, the current state when the breakpoint was hit. Now, a couple of interesting ones include, of course, EIP. right? And basically the other one which you're already guessing is ESP, which is probably interesting in our case because looks like, you know, we have a stack based overflow, and there is a bunch of other stuff as well which we needn't worry about. Now in later videos we will look at how to disassemble specific functions and things like that. I would encourage you, if you get time, to have a look at the assembly language mega primer for Linux, which I had created a while back. This is 32-bit assembly on a Linux platform, and this would give you a very good idea about all the different registers, how they are used, the different assembly language instructions and all of that. So this is highly recommended watch if you're probably planning to use GDB to do exploit research or reverse engineering. Right, coming back. Now, what we said was that we've created a breakpoint. You can create a breakpoint before the program runs. You can run the program, it's going to hit the breakpoint. Now, you can actually create additional breakpoints when you're currently at a breakpoint and the program is frozen, by the way. So if I were to create an additional breakpoint, so let's go ahead and say, you know, we want to break at this function echo input, right? So what I'm going to do is again break echo input, and the second breakpoint has been set, right? It says line 16. Line 16 is basically nothing but the start of the echo input function, right? Now we have two breakpoints, but the question is, how do we look at all of this info? So you can just do a quick info breakpoints, and this is going to go ahead and give you all the breakpoints. As you can see, we have two of them, and after that it would even tell you if the breakpoint is enabled, YY is yes, and it says that this breakpoint, which is the first one, which was for the main function, has already been hit one time, right? Now you can also enable and disable breakpoints. You can delete breakpoints. So as an example, I could just say, hey, you know, disable the first breakpoint, which was at main, right? GDB is pretty cryptic in its response, but if you do an info breakpoints again, you'll actually see that under the E and B column, the first breakpoint is now no, N, or basically it's not enabled. It is actually very simple again to enable the breakpoint. So you can just say enable and then one again, go back there, and if you notice, now we've enabled the breakpoint back again. You could delete the breakpoint as well by just saying delete, comma, you know, the list of breakpoints, in this case just the first one. Again, we do info breakpoints, and if you notice, there's only one breakpoint, right? Now the important thing is that if you delete a breakpoint, that does not mean all the numbers change, right? The number remains the same for the entire run of GDB, which means that, you know, this 2 is not going to become a 1 because you deleted the first one, right? This is of course expected, because or else you would never be able to keep track of all these breakpoints in a sensible way. Now you can go ahead and again add the breakpoint by saying break main, which means when we do info breakpoints once again, you would find that the main breakpoint has been added, but as I'd mentioned previously, now it's added with num3, right? Awesome. So what we've learned is how to break at functions, how to enable, disable breakpoints, delete them, and now let's look at what else we can do when we've hit the breakpoint. So one of the things I mentioned is, hey, you can look at the registers. The other very important thing is the capability to examine memory, right? This could mean the stack. This could probably mean the binary code which is loaded in the text section, anything for that matter in the program space. How do we do that? To examine memory, there is a very simple command called examine or X, right? Help X gives you an even more simple to use help statement, and the format of X or examine is X/format followed by the address you want to examine, right? Now let's actually go ahead and first look at an address you want to examine. Now, you had mentioned argv1 as Vivek, right? So let's try and use another little helpful command called print and say argv1. If you notice, it tells us argv1 is Vivek and argv0 is nothing but the absolute path of the program which is executing, right? So now let's say we want to go ahead and print the memory location argv, right? We want to really look at what's there in argv. So how do we do that? So we say x. Now the format consists of three things. The first thing is actually a repeat count, which is the number of such items which you want to examine beginning at that address, right? The format letter is basically how do you want to go ahead and display all of this. So which basically means in octal, hex, decimal, unsigned, decimal, blah, blah, blah. The interesting ones include address, string, right? Address, string, and probably hex. The final option is the size, which is basically the size letter, which could be byte, half word, word, giant, and in other architectures you could have more options as well. So we know that basically argv1 is pointing to a string Vivek. So if you just want to print one item beginning that address, you can ignore the one. And the format we really want is a string, right? Which is right here. So all I'm going to do is XS, and I'm going to say, hey, argv1, right? Similarly, you could actually print argv0. Awesome. Now, what are the other things which we can do? Now, if you remember, we had our little friend, the EIP register. So info registers, let's clear the screen, EIP, right? So EIP is actually pointing to the instruction to be executed next, right? Now, if you look at it, already tells you this is main plus 9, which is, some place in main, and this is the address. Something we'll look at in a later video, but if you want to disassemble a specific function, you can actually use the disassemble command and give it the function name, main, as an example in our case, right? And what you would see is, while GDB is actually running, you'll see this little sign here, which actually goes ahead and tells you where currently EIP is actually pointing, right? Which is this address, right? It's basically plus 9, that's the offset. Now, what if you wanted to go ahead and probably use the examine command to look at this specific address, right? So let's copy it. Now, if you do a quick help examine, what you note is there is also an option to print an instruction, which means examine will automatically start decoding those instructions and try to give you the assembly language equivalent. Now, how would you go ahead and do all of that? So let's say use examine. Now, probably you want to just print one instruction, give it the address. Once you give the address, you can go ahead and hit enter. And if you notice, this specific instruction has been decoded, move 0C blah blah blah, which is nothing but this instruction here, right? Awesome. Now let's say if you wanted to decode more than one instruction at that specific location, there you go, right? Which is similar to what we've seen when we did disassemble main. Now you're probably thinking, well, why do we really need to kind of worry about all of this and everything? Well, many a times when later on in probably other things like exploit research, you have things like shell code and all of that loaded in memory, and you're probably thinking, hey, is the shell code loaded properly? Has it been modified? Or let's say while reversing, you're probably looking at some sort of polymorphic code, which is doing a bunch of interesting things, and you probably want to look at, hey, how does it look like right now? Have the instructions all been kind of, decrypted, decoded, and all of the stuff has happened? This command comes very, very handy, right? Now, one of the other things which you can also do is print stuff as hex. So in which, of course, the favorite option is always going to be the ESP register, which points to the stack. So one of the other options is you can just do an X. Let's say you want to print 10 of them, and going to basically print them in hex and say, hey, word. And then if you want to print what ESP points to, similar to what we've basically done here, you can either take the address directly and copy it, or you can just say $ESP, right? Awesome. And alternately, you can actually do, kind of print as many as you like. Blah, blah, blah. Right now, there is a bunch of stuff which you can probably start looking at. In this case, you want to examine the stack and look at what all is there on the stack, and things like that when you come to things like buffer overflow. So what I would tell you is play along with examine. It's a very, very useful command. You can print out, arg v, or v0, or v, I mean, pretty much anything which is a valid address in the program's memory, right? You could go ahead and examine that piece of memory, right? Awesome. So coming back, different options. One of the others, of course, is to break by a specific address as well. Now, what do we mean by that? Well, this comes in very, very handy when you're probably playing with things at an assembly language level, right? Per instruction level. So let's say I basically do a disassemble main, and if I look at info breakpoints, right, we have two breakpoints. One of them is at this location, and the other one is basically at this location, right? Now, let's say you wanted to add a specific breakpoint, probably here at this location, right, for whatever reason. Typically, you add a breakpoint just after a function comes back to actually go ahead and check what the function returned and things like that, right? So one of the options actually is to set a breakpoint by just mentioning the address. You need the asterisk before the address, and you can actually set the breakpoint at that specific address. So now if you look at breakpoints, you'll actually see that an additional breakpoint number 4 has been added. Right, awesome. Now with all of these breakpoints in place, you can continue the execution of your program by hitting C, or probably by going ahead and typing in continue, and where any subsequent breakpoints may be hit. You have something called step I, which is on a per instruction basis you can execute. I'll leave it as an exercise to you to probably look at what this means. You also have something called basically step, which is almost like on a per line in the code after execution when things happen, which is basically behind the scenes step is like you're actually correlating that with the code rather than at a per assembly language instruction. What I mean is printf is basically a huge series of instructions put together, if you think of it from a disassembled perspective, right? Step I is basically go through each of these instructions, while step is on a per line basis, which you can figure out by hitting help step, and it says, hey, step program until it reaches a different source line, which is basically the next source line, And you also have step I, which is on a per instruction basis, right? There you go, right? Step 1 instruction exactly. And as you can well imagine, both of these have an argument, n, which is, well, instead of just stepping one line, or instead of step I stepping just one instruction, you can do a couple of them, which sometimes, depending on where you are in the program, you can even decide to look at and figure out how many instructions you really want to step, right? Coming back to the slide, so we've looked at examining CPU registers, memory, program flow, view all breakpoints with info breakpoints, enable, disable them with disable, enable, and then delete. And that's all for this video, right? In the next video, we will look at a couple of more interesting things, what you can do with breakpoints, or more of what you can do when you hit a breakpoint, right? And how program flow and all of that can actually be changed a little bit. So if you want the slides as well as the binary and the code for this video, request you to either tweet the video, or if you really can afford, we'll be very thankful if you can register for the SGDE at $50. That's all for this video. Have a great day ahead. Bye-bye.